Hi class, this is Professor Teixeira. In this video, I'm going to show you how to construct an X-bar chart for statistical quality control. This is the slide I'm referring to. Has a case, has an example here. A quality control inspector at a company, a soft drink company, takes 25 samples with 4 observations each of these samples with the volume of bottles filled. We have information about that in example 6.1 in the text. Here is the example 6.1 in the text, has all the data, okay, has the observations, the volume in ounces in each one of 4 bottles that are taken in 25 samples. So the inspector gets one sample of 4 bottles, a second sample of 4 bottles, and keep doing that 25 times, okay? So we know the information given is that the standard deviation of this bottling operation is 0.13 ounce. So that's the standard deviation given. And then we're gonna use this information to develop a control limit of 3 standard deviations below and above and below the mean, okay? So I'm gonna show you how to do that. I'm using this data here in an Excel file, and I'm going to start from scratch to show you how to build that. So here is each one of the bottles. And you could see that we have sample number. How do they say? Sample number. Okay, sample number. Okay, let's see, let's make it. So we have 1, 2, 3, and so on. We have 25 observations of 4 bottles of water, and this is the amount in ounces in each one of the bottles. Okay, so we have some steps to take here. First one is take the average of each sample. How we do that? We come here in the same row for sample number 1, type equal average. Okay, I did too quick, maybe equal average, open parentheses, and then I have to enter the data. I come here and I select these 4 rows, which is, I want the average for this sample. Then I do that again, equal average for the second sample. Okay, I keep doing that. I could do this manually, but I can simply copy the formula over until the last one. Go to the top, go to the formula function bar here, and just make sure that is highlighting the last sample to make sure I'm getting the correct data. Okay, and also what I have to do is equal average, get a last average, which is the average of the averages here. Okay, so this is the average of the averages, also known as X bar bar. If we look here in the slides, this is the X bar bar. We are summing the averages for each sample and dividing by the number of samples. Okay, we're going to use this average of the averages to determine the center of our limits. Okay, so let's go back there. All right, so number of samples we know is 25. Number of observations per sample is 4. We have 4 bottles in each sample. Now what we need is, what is the sample mean? Our X bar bar is going to be equal to this average. What is the sigma in the process? The sigma for the process is the standard deviation, this one. The standard deviation here, that's the sigma. That's the sigma we have in this formula. Okay, so the sigma is given 0.14 ounces. Now we have to compute the standard error of the mean. What is the standard error of the mean? This is the standard error of the mean. Okay, we divide the standard deviation given in the problem by the square root of the number of samples. Okay, so what we do is equal the sigma divided by And then we use a function in Excel which is sqrt for square root, open parentheses, and we select the number of samples. I'm sorry, the number of observations in each sample. Okay? We use the number of observations in each sample. All right, so now we have the standard error of the mean. So going back to the slides, referring to the slides, we are building the upper control limit and the low control limit. We have the average of the averages, which is x bar bar, and now we know the standard error of the mean, the sample mean, I'm sorry. Now we have to find the z. How much is the z? Is given here. 3 standard deviations away from the mean. The z then is equal to 3. Z for control chart is 3. Okay. So what is my center line? My center line is going to be my sample mean, x bar bar. What is my lower control limit? My lower control limit is going to be the center equal the center minus 3 times, that's my standard deviation, 3 times the standard error of the mean. Okay, so if I click that, I get my lower control limit. I can reduce the number of decimals to keep 2 decimals. Then what is my upper control limit? It's going to be equal to my central line plus the number of standard deviations. I can type or I can select 3 times, let's do it again, equal center line plus standard, the z value for the standard deviations that I want away from the mean. Oh my God. So let's do it again. Times the standard error. So this is going to be my lower and upper control limit. So what I do is I come here and I'm going to type to make it easy 15.74, and I can simply double click here. When I turn this into a black cross, I can double click and it copies to all cells, and the upper control limit is 16.16, and I can also do the same or simply drag until the last one. We have 2 additional here. All right, I have the center line and I have the lower and upper control limit. So what I do, I come here and highlight these 3 columns, go to the insert tab, and then look for the charts, go to recommended charts, and here in the second one I have the chart we want, which is the, what do we call it? How can we call it? X bar chart. So we can even like change that X bar chart. Okay, I'm not going to spend too much time formatting, but for example, I know that you can come here and other suggestions also come up. Like you can put the numbers or simply like, I don't know, change the format. Let's keep it simple. How can I go back to my simple one? No, all of them have like now too much information. Let me see this first one. So let me go back to my X bar chart. So what this X bar chart is saying is that I got 25 samples. These samples vary in the amount of ounces on average that the bottles have, but none of them is out of the control limits. None of them is below the lower control limit. None of them is above the upper control limit. So that's how manufacturing companies control how much variability they have in their products. And they do that by controlling the amount of standard deviations. This tree is telling how many deviations away from the mean we tolerate variance, okay? Again, that's an acceptable variability. If it goes away from the limits, then companies stop and try to figure out what's happening in the processes. But that's how you build the X bar chart.